Hello everyone, welcome to another video. In this video I'm going to talk about a tricky sequence. Like I have named this sequence as a tricky sequence. So this question was also asked in one of the interview sessions while like in the ISI entrance exam. Now what is the problem? So the problem is saying that you have like these numbers 1 2 3 4 5 6 7 8, okay, and you have to make a sequence with certain condition. That is, suppose whatever you are placing at any like kth place, so obviously you have the length of the sequence will be 8 because you are making it with 8 distinct numbers. But at suppose whatever you are placing in the suppose fourth place, so all the numbers before it should be all smaller than that or should all be greater than that, okay. So obviously you can understand whoever is sitting in the front doesn't have any criteria or condition. Whoever is sitting in the second place, so the first one has to be either smaller than that or bigger than that. So obviously that will be true again because all these numbers are distinct. But the thing starts from, actually the main action starts from the third point, okay. So whoever sitting in the third one, so the previous two will have to be like whoever sitting in the first and the second, so they both of them has to be greater than the third or have to be smaller than the third, and so on and so forth. You have to continue and make a sequence, okay. So once you make a sequence, so that makes your count +1. So the question is how many such sequences you can make, okay. So if you hearing this problem for the first time, so please do try it out. It's a very nice problem. So you just have to think, okay, no calculation or not much calculation or anything. And also like talking about like if you want to generalize this thing, so this 8 is nothing special, or 1 2 3 4 5 6 7 8 is also nothing special. So like you can understand, like, we can do it with n distinct natural numbers as well, or n distinct integers as well, okay. So now coming down to the problem, so a little bit of discussion, like I have seen many students how they approach is basically we also mostly approach when we start go with the help when we try to count something like these type of things, like so what we do is we check how many possibilities are there for the first place, and for that how many possibilities are there for the second place, and so on and so forth, okay. And finally like we apply the multiplication principle. But here the problem is that I have seen students approaching like that, but try to understand the problem with that. Basically anyone can sit in the first place, okay, but then if you let anyone sit in the first place, then will it satisfy, okay, will it satisfy as you go on, okay. And whoever sits in the second first place, also in the second place you can choose any one of them and put it there, okay. But then like I mean with that can you complete the sequence? So it might happen that for some cases you might not be able to complete the sequence, okay. So try it out on your own, take some examples, like try to form some examples, and you'll see that so for some you won't be even able to complete the sequence. So now as an example like which works as given, 4 5 6 3 2 7 1 8. At any point if you look at here, that is let's look at 3. So before 3 we have 4 5 6, all are greater, okay. So let's look at 7. So 7 before that all are smaller than 7, okay. So now the question is that then how can we approach? So the approach is pretty simple. It's a one line solution. So again those who wants to try it out, so don't pause the video and try it out and then look at the solution, okay. So we have 1 2 3 4 5 6 7 8, okay. So these 8 places are there. This is the number, okay. And now what we are going to do is we are going to approach it from the back, because what happens is that here the main concern is that whoever is sitting before any place, okay. So like the last place, why I'm starting with the last place, because whoever is sitting before them will all be either greater than that or will all be smaller than that, because the condition is given like as you can read here, that is the numbers which precedes, so that means those numbers which are before them. So that's why like starting with the last one, so as I can see that since whatever sits at the last place, so before them all has to be greater than that or all has to be smaller than that. So I have only two possibilities. Okay, so that means I can, whatever be the set, so I can only put the maxima or the minima at the last place. Okay, because only then I'll have all of them like before whoever sits whatever sits in these 7 places, so all of them will be smaller than that or all of them will be bigger than that. So if I put the maxima, all of them will be smaller. If I put the minima, all of them will be bigger. If I put any other number, so the condition won't satisfy. So now what that means either 1 or 8 according to this example. Again, you can generalize as well. So according to this example, like either 1 or 8 can sit here. So that means 2 choices for the last place. Now whichever sits there, okay. So now again when I go for the second last place, so again whatever the remaining set, okay, whoever sits, like if 8 sits, so then I'll delete 8 and the remaining set, again the same logic, that is from that remaining set again the maxima or the minima can sit here, okay, at the second last place. So again it will have two choices and so on and so forth. Every place will have those either whatever be the deleted set or the leftover set. So from there either maxima or minima can sit, okay. So likewise while you reach the second place, so you will be done with the 7 numbers and only one number will be left. So the finally the first place will only have one choice, okay, whoever remains. So also students try to they make this mistake because every place is having 2 choices, so 2 to the power 8. No, it's basically like 2 to the power 7, okay, fine. So that's the answer. So again as I said, like you can even generalize this and you can generalize it and you can comment below. So what will happen if I have like n numbers, okay, n distinct suppose natural numbers. So again they might not have to be consecutive as well because we are only concerned about all of them are really smaller or bigger. So any n distinct natural numbers or even integers will also do the job, okay. So yeah, that's it for this video. So thanks for watching, and again our workshop or the crash course for the ISI entrance exam is going to start this week. So if you are interested, you can contact us or visit our website and look into the courses and all the details are given there. So yeah, that's it for this video. See you in the next one.